Okay, so let's go ahead and try to do one last ellipse, and we'll do one where it's not set up as nicely. So we know an equation of ellipse is x squared over a squared plus y squared over b squared equals 1, meaning we need this to equal 1 at some point, and we need this to be some stuff over some other stuff squared. And we notice that we got x squareds, y squareds, but we also have x's and y's, which means we're probably going to have to complete the square. So that way we can just get one term on the top squared and then maybe shift some things like we did in the last problem. So I'm going to write my x's together, 3x squared minus 6x, my y's together, 4y squared minus 24y equals negative 3. And if I'm going to complete square, I don't want a number in front of my squared term. So I'm going to factor out a 3, so x squared minus 2x. I'm going to leave some space. And I'm going to factor out a 4, y squared minus 6x. I'm going to leave some space. I'm going to leave some space because I know I want this now to factor to a perfect square, so the exact same parentheses squared. So now that's just an x, I can do x and x. I don't know this, so I can't say things that multiply this, but I do know the same number that adds to 2. So 1 and 1, it's minus 2, so minus 1 and minus 1. The only way for this to actually factor this is if I have a plus 1 right here. Of course, if I add a plus 1 on this side, I have to add a plus 1 on this side. But I'm not actually adding a 1, I'm adding a 1 times 3. So I'm going to add a 3 on this side. Okay, so this is now a perfect square. So I'm going to do the same thing to the other side. I guess I should draw my 3 all the way down. So y and y. Don't know this number, but the same number that adds a 6 would be 3, so I want this to be minus 3 and minus 3. So I need a plus 9 here. Of course, I'm not actually adding a 9, I'm adding a 9 times 4. So plus 36 here. So this is now a perfect square. Y minus 3, whole thing squared, equals negative 3 plus 3 is 0, plus 36 is 36. Okay, I need it to equal 1 though. So I'm going to divide everything by 36. So I'm going to get x minus 3, whole thing squared, over 12, plus y minus 3, whole thing squared, over 9 equals 1. Now I can start graphing. So I can draw the stuff on my ellipse. I'm going to write this as square root of 12, this as 3. And if I graph this, I'll go ahead and graph it over here. I'll graph it without the shift first. So on my y's, it goes up to 3 and down to 3. On my x's, though, it goes to square root of 12. Well, square root of 12 would be between 4 and 3, because square root of 9 would be 3, square root of 16 would be 4. So I'll put it in between 3 and 4, so somewhere there. Okay, so now I need to write a few things. So I'm going to write out my vertices, my major axis, my minor axis, and my foci. Oh, and I guess my eccentricity. So my vertices are still just my larger. In this case, something between 3 and 4 is bigger than 3. And I mean, look at this. My square root of 12 is going to be greater than my square root of 9. And it's on my x, so I'm going to get, I should simplify it, 2 root 3, 0, and negative 2 root 3, 0. Okay, so my major axis, longer, is on my x. That would be 2 root 3 plus 2 root 3, or 4 root 3. Minor axis, smaller is along my y, so it'll be 3 plus 3, so 6. Foci is just c squared, is my larger minus my smaller, and it's larger squared, but again, we can just look at denominators. So 12 minus 9, so c should equal square root of 3. Again, plus or minus, and that should have to be on our x, because that's where our major axis is. So square root of 3 is 0. Negative square root of 3, 0. My eccentricity is just a foci over my larger vertices, so 2 root 3, so 1/2. Okay, so that is it without the shift. If I shift, this is going, oh shoot, this is a 1. I don't know why I wrote that as a 3, so hopefully you all got that I was wrong. So this is going right 1, up 3, because both are inside, so they're going the opposite way. So I'm going to move each of my points right 1, up 3. So if I do that, this point here would go right 1, up 1, 2, 3, so somewhere up here. This would go right 1, up 1, 2, 3, so it'd be on my axis. This would go right 1, so somewhere in between 2 and 3, up 3. Right 1 and up 3. So my shifted would look like that. And it changed my vertices. My vertices with the shift goes right 1, so it moved my x right 1. So I'm going to get 2 root 3 plus 1, because moving right would be adding it, and up 3, so up to 3. And negative 2 root 3 plus 1, 3. My major axis is the same, since it's a distance, same with minor axis. My foci changed, square root of 3, right 1, so plus 1, up 3. And negative square root of 3 plus 1, and then up 3, so my y went up 3. And my eccentricity stays the same. So this is the graph and the, I guess, important points of this ellipse.